So this is the third recording. Unfortunately, I had to split this into 3 recordings because I kept having to use my computer for other applications, like teaching other classes. So I had to stop the recording while I recorded the other class. So this lab has actually been split up into 3 labs, 3 different recordings, 1 lab, 3 different recordings. So where we're at, we're down here on the last section of this lab. Where we're going to use the data switches, and we're going to use a 74147, which is an encoder. So what we're going to do is we're going to bring our inputs in. This has inputs from 1 through 9, and this would be like out of if I was using a 7442 4 to 10 decoder. Then the inputs, so it has 10 outputs, be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then this right here would work perfect. So I could hook this up directly to the output of a 7442, which is a 4 to 10 decoder, or BCD to decimal decoder. We're going to bring this in, and we're going to bring in a supposedly a decimal number from 0 through 9. Okay, and then this guy's going to decode it, and it's going to output a binary equivalent. This would be the least significant bit. This is kind of like the data on the other chip that we used, where most of your chips are going to call them A, B, C, and D. This is called an A0, which would be the least significant output. So this would be the A output, B, C, D. Now, the problem is this has a low active output, and the 7447 binary to 7-segment decoder has a high active input. So what we're doing to see this work, guys, we're putting an inverter. So I'm using a 7404. So we have a 7404 here, and I'm using the first 4 inverters. So this would be the one between 1 and 2. This would be between 2 and 3. 4 and 5, 6 and 7. Okay, guys, I got another interruption. So here we go. This is the last circuit we're going to check up, and I think I've already told y'all this is an encoder. It's a 10 to 4 encoder. So what it's going to do is going to take a decimal number over here between 0, which is not shown. So if I don't have 1, if none of these are true, then of course that means it's a 0. This is going to, it's low active input, so this would come out of either a 7442, which has a low active outputs, which is a 4 to 10, so this would come right out of that thing. Or it could come out of a 74154, which is a 4 to 16, but we wouldn't be able to use this. We would have to use another one in parallel with it or next to it. 74138, which is a 3 to 8 or octal decoder, we would just use the first 8 inputs. The first 8 inputs on that one, 0 through 7. Okay. So what we're going to do are the first 7 inputs, because 0 is understood. Okay. So this is basically the same circuit we had before. This is a 74LS47, and what I'm going to do is I'm going to bring up a PowerPoint so I can make or do some notes on it for you. So there's a little difference here. One thing we've done is on the 7447, if you notice, we've done away with the lamp test, the ripple blanking in, and the ripple blanking input. So what I've done over here is I've connected those, and I have these all connected to a pull-up resistor up to 5 volts. So this is different from the other circuit. Also, we got to remember, this is basically a schematic. And when we get into a schematic, what they don't do on digital is, one thing they don't do is they don't show the power pins. And of course, why they do that is they know that if you've got enough sense to be working on these things, then you've got enough sense to know you got to connect power to these circuits. So what I'm going to do here is just show y'all the power pins, and we're not doing the pin out like we did on the other ones. So the power pins, if we look it up on the data sheet, the power pin for this is pin 16. So this would go to VCC, and then pin 8 would go to common. Okay. So we have those two pins, and then we have the lamp test we're not using, which would be pin 3, and then we have the blanking in, ripple blanking out, which goes to pin 4, and then we have the ripple blanking in, which would be pin 5. And of course, this is pin 6 on the 74. This is pin 2. This is pin 1, pin 7. I'm looking at the pin out. And this would be pin 13, as we did before. This would be pin 12. This would be pin 11. This would be pin 9. I'm sorry, 11. This would be pin 10. This would be pin 9. This would be pin 15. This would be pin 14. And the power pins for this is 16. We already did this one. It's in the previous one circuit that we hooked up. And then pin 8. This is a 7404 or 74 LS04. So we're going to use pin 1s and 2, 3 and 4, 5 and 6, and 8 and 9. I'm sorry, 9 is an input, 9 and 8. These are our outputs. You have to look on the data sheet. This is called A, B, C, and D. Very similar to the 7447. So this is pin 9. This is pin 7. This is pin 2. And this is pin 6. So whatever binary code I put in here, inverted binary. So if I want to put a 9 into this thing, I would come over here and I'd make this one switch 0, and I'd leave all these high. I'm sorry, that's not a 9 that way. And then the display should come up and say that, then it should turn on the number 1. When this one goes low, this should turn on the number 2. When this one goes low, it should come up number 3, and all the way up to number 9. Now, the problem is on our trainer, all we have, so on this one, I'm using switch 0. Here I'm using switch 1, 2, 3, 4, 5, 6, 7, and 8. And that's all. I'm sorry, I skipped one. I'm sorry, we don't have an 8. So what I'm doing with this one is I have it disconnected. Of course, what I do is I have this one disconnected, and all I'm doing is running a jumper. Okay, so I'm taking this wire right here, and I'm either going to come up here and I'm going to connect it up to +5, or I'm going to connect it down to common. So what I'm doing is I'm simulating this switch with a wire. So what I'm doing is I actually don't have the switch, so I need to just take that off. So I'm either taking this wire right here, since we don't have but 8 switches, and I'm taking this wire right here, and I'm either going to connect it up to +5 ohms, or I'm going to connect it to common to simulate the number 9. So the way this thing works, when all these are open, then my 7-segment display, all these should be 1s, because it's a 0, right? You understand? These are inverted. So you got to remember these are inverted outputs. So if they're inverted, this right here would actually equal this binary number right here, because they're inverted, right? You understand? So when this thing puts all 1s, that'll put all 0s into my 7447, and then my display should come up here and display a 0. And then when I close this switch, which actually is a 1, so this is a 1, 2, 3. This is the actual input. I'm just going to transpose them up here to make it easier to see. 4, 5, 6, 7, 8, and 9. So when I close this switch, it should display a 1. When I close this switch, it just should display a 2, 3, 4, 5, 6, 7, 8, and then I'll have to jump this to get the 9. Okay. So also we have this hooked up right down here. I'm not using 220 ohms. I'm still using our 330 ohm reach. And so all I did, everything down here is the same from the last circuit. So we know that the A is pin 1, the B would be pin 13, the C would be pin 10, the D 10, the D is pin 8, the E is pin 7, the F is pin 2, that's a 7, and then the G is pin 11. So I have this hooked to that and vice versa. So this is still my resistor pack. And I showed you how that thing works, so that saves us a lot of time and effort on trying to hook up all these resistors. So this is our circuit. So here is my 7-segment display. Right now it's displaying a 0. Here's my resistor pack. So I didn't have to rewire this. This is my 7447. I don't know if it's a 47 or an LS47. So I didn't have to rewire the wires going from my 7447 to our current limiting resistors. So this is my 7404, which is my inverter. This is my 74157, which is my encoder. My decimal to binary or my decimal to BCD encoder. Okay. So what this is doing is taking a decimal, a single input that represents a decimal number, and then it's converting it to BCD. So I'm going to come up here now. So right now I have I'm saying I have all these highs. So these are low active. So right now I'm putting a 0 into the thing. So it's going to come up here and it's going to display a what? A 0. Okay. So if I come over here, I'll try to get this a little closer so we can see the switches also. Got to move my wheelchair over a little bit. We can actually see the switches and the circuit. So here is 1, even though it's a 0 switch, here's 1. So if I do this one, it should be seeing a 1. So it does, and it displays a 1. Let me get this out of the way. So here it displays a 1. And then this would be a 2. So this is not binary, this is decimal. So this is 0. This would be 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to have to jump a 9. So here's my jumper right here. Right now I have it going to a high because it's a low active input. So this is 0 and it's displaying a 0. This is 1. This would be a 2. This would be a 3. This would be a 4. This would be a 5. This would be a 6. This would be a 7. This would be an 8. Then I would come over and simulate this. I'm going to take this red wire right here and I'm going to move it over to ground, and it should display, wrong thing. Take this wire right here, I got to stand up right here, and then I'm going to move it over to ground, pull it out, and it should display a 9 as soon as I do this. Here, I'm going over to minus, I'm going over to common, and it should display a 9. So there's a 9. And then take it over here to this, and then it should go back to 0. Now this is actually what they call a priority encoder too. So I'm going to show you what we mean. So normally what we do, this right here would be a 1, right? Understand? So notice what I did a while ago. I flipped this up and went back to this would be a 2. Well, what I'm going to do is I'm going to come over here and push down the 1. And I'm going to leave it down, and I'm going to come over here and push down the 2. And it went to 2. So it's saying the 2 has a higher priority than the 1. And I'm going to come here and flip the 3, and it goes to 3. So the 3 has a higher priority than the 1. So I can come over here, that's a 1, and I come over here and do 3, and it still goes to 3. So the 3 has a higher priority than any switches down below that. So that's going to be a 4, 5, 6, 7, 8, and I'm not going to jump the 9 out because I have to stand up and do it. Okay. So this is why it's called, if we look it up in the data sheet, it's going to say it's a 10 to 4 line encoder, or it's going to say, it's a priority decoder, which means I could do it one or two ways. I could come over here and do this, or I can just leave that down and do that. So the circuit itself looks very impressive. All the wiring and stuff gone, and this is what we get into with digital. It requires a lot of wiring, but the problem is, if I was to do all the bipolar transistors and everything that's inside this one chip, right? If I was to do it with transistors, we would probably have, 15 to 20 times the number of wires just for that one little circuit right there. So it seems like we have a lot of wires to do this, to connect this circuit up. But if we had to connect this up using bipolar transistors, guys, that would probably be 20 times more wire than we would have connected there, even more. And not only that, but just for every inverter right here, that is 5 transistors just to do one inverter. I'm using 4 inverters. So 5 transistors and all the wires and all the resistors to connect those together. And if you think about the number of components that would be required just to replace this one IC and the amount of wiring that would be to replace that one IC, this is nothing. This is nothing according to that. But what you have to do when you wire these things up, you got to make sure that you come up and do these pin outs first, right? You understand? And then you're connecting to numbers. Pin number 7 on this chip to pin number 7 on that. I wired this up. I don't know how long it took me because it was 2 circuits. But first time, it operated right the first time because I did, I practiced what I preached. Okay, so what we're going to do is, in this one, when we look at the lab, we don't have to do a truth table or anything on this circuit. But one thing we do have to do, one thing you are going to have to do, is right here. It says I'm going to have to write a summary of what this whole circuit does. So this is a 10 to 4 line decoder, right? You understand? It uses low active inputs. It uses low active outputs. Oh, by the way, I didn't give you the power pins on the 7404. They're pin 14 and pin 7. But this is the schematic, and the schematic they don't include the power pins because, like they said, they think you have enough sense to know that these integrated circuits are going to have power applied to them right before they operate. So that's what you're going to be required there, and of course you're going to have to do the questions on the test. It asks you about a 74147. It asks you about the priority encoder, and I told you exactly what that is. It wants to know the difference between the BCD to decimal decoder, which is a 7442, and a BCD to 7-segment decoder. We talked about that. If converting optical to binary, what chip would be used? I'll tell you that. It will be a 74138. You can look that up. What is the difference between a 74142 and a 74LS45? What you need to do is you need to look those 2 data sheets up on the internet and write down what the difference is. Using AND in order to draw a schematic for a converting from decimal to 0. So what we're going to do is we're going to skip number 5. So we don't teach design in this class. All we are going to do is teach how the circuits operate. So that's the lab, guys. I had to split it into 3 different lectures because I kept having to stop the lecture so I could use my computer for other things. So I split it into 3 different lectures. So what we'll do now is I got to run over to another class, and then I'll come back and we'll look at lab number, what's our next lab? We'll look at lab 14, multiplexers and demultiplexers. Those will be the two labs that you'll be required to do.